area between curves, yes? And in doing that, we've kind of gone through number one, which kind of had us exploring a little bit, right? And the idea, if I backtrack real quick, how would you find the area of the region that lies between the two graphs, right? So that would have been that area kind of outlined in that bluish, and it was going to be subtracting the f of x minus g of x, the upper minus the lower, okay? I don't know if we talked about, but on the interval 0 to 5, because that's the x value of 0, and that's the x value of 5. I'm going to need to change off of white. White is not going to work. Okay. We're ready for 3. And 3 asks us, or it talks about, when we talk about the function of expressed as y's. So, with this one here, sorry, I'm trying to piece together what we talked about on Friday. There was, when we think about the difference between the two, it is a vertical piece, okay? That's a vertical, and we refer to them as rectangles because when we think about, you're summing up all those rectangles. So they're vertical rectangles. When we look at a situation like this, we can't do a vertical rectangle where we're always going to have an upper minus lower. Okay, and so we're going to talk about horizontal rectangles. When we switch over to talking about horizontal rectangles, okay, I've already previewed this, right? That instead of talking upper minus lower, we're going to talk right minus left. So we're going to be looking at the distance between those two curves from right to left. Okay, now the question officially asks us to find the area of the region bounded by the graphs of x equals 3 minus y squared, which realize x equals 3 minus y squared is this sideways parabola. Whoops. Minus y squared means it's reflected and opens left. The 3 means that vertex is shifted right 3. Okay, and then x equals y plus 1. Well, that's a line, right? If you switch it to y equals mx plus b form, you have a negative y-intercept and a slope of 1. Okay. Now, there's a note there. WRT and WRT is with respect to. Okay, so the note talks about if we're going to do this problem with respect to x. So that would be doing upper minus lower. There is never one curve that's always on top. From here to here, the line would be on top, wouldn't it? But then what happens over here? Then we have just a parabola, and you don't have that line involved at all. And so with respect, should not have done that. Okay, so with respect to x, you would have to have two pieces. You'd have to have the piece from -1 over to 2, and you'd have to have a separate piece from 2 to 3. With respect to y, this is why we're going to do this one horizontally, we only need one integral. Okay? And when we talk about with respect to y, we're going to use y values. So as we look at these intersection points, what are these intersection points? Okay. And if I look at this ordered pair real quick, what is this as an ordered pair? It is -1, -2. And this one is 2, 1. Because we're doing right to left, because we're going to talk about with respect to y, notice it gives the values -2 to 1, which means it's giving us what kind of values? Y values. Okay, so when you are integrating right to left, you're working in terms of y and with y values. So y variables and y values. Okay? Let's see. I'm going to go ahead and write, I see in my notes I have written on here with respect to y. In case you look back at that later and say, what the heck was that?
Can you not?
What she says. Okay. In reflection to the, bless you. Okay, so let's set up our, I'm going to say A equals, because we're trying to find the area. right minus left. So it's going to be the integral. What is my right curve? Which curve is on the right side here?
The parabola.
The parabola piece, yes, which is the one that is x equals 3 minus y squared. So it's already x equals. So this is going to be 3 minus y squared. We're doing right minus left. So that's my right curve. What's my left curve?
Y plus 1.
It's that line, which is already solved for x equals y plus 1. So it's going to be minus the y plus 1. This is with respect to y, so we're going to say dy at the end. My boundaries. Lower y value to upper y value.
-2.
And that's the -2 to 1. Okay? If we had done upper minus lower and we were working with x's, we'd want the x values. Okay. Options of where you'd like to go here. We have two options of where we could go at this point. It's really a personal choice. What'd you say? Okay, one option is integrate.
Is this one of the ones where you have to flip it and put the negative out front? No, that's whenever it goes from a positive to a negative, right? Yeah.
From a negative to a positive.
Oh, when the bounds are upside down.
Yeah.
Okay,
Never mind.
I agree. Never mind. I'm sorry. I was
Sorry.
trying. I was like, what is she talking about? What is she talking about? Okay, so we can integrate. What is a preliminary step we could do to integrate if we saw it and wanted to?
Like terms.
Could we clean up like terms here? Do we have to?
No,
No.
but probably be ideal.
Okay. The only advantage, and there's nothing wrong with just integrating. The only slight advantage is we'll have 3 terms to integrate instead of 4 terms, and you have 3 terms to plug into instead of 4 terms. Okay. Again, not a requirement, but it is an option. So integral from -2 to 1. If I clean this up, what do you guys see? Okay. Okay.
Plus 2.
What?
There's a positive 3 minus 8.
Oh.
Are you guys good with this?
Yeah.
He also, as he cleaned it up in like terms, he reordered it, yes?
Mm-hmm.
So it's a minus y squared pulled down, minus y, because it's being subtracted, and then it's 3 minus 1.
We haven't integrated.
No, I'm not integrating yet.
Oh, I was getting ready to integrate it.
I'm going to integrate now. Okay. Integrate and meet me. Integrate on your own. Okay. I wrote down the integration. After you get yours, check against mine.
Yes.
This saves the arguments, right? Add 1 to the power, divide by the new power, right?
Shoot.
Don't make careless mistakes, right?
Yeah,
Nice.
mine.
I accidentally won.
Well, okay, so -1/3 y cubed minus 1/2 y squared plus 2y.
I forgot one.
Now we're going to evaluate. So I'm putting the 1 in for everything. I don't know about you guys, but I just put that 1 in and did all the math on each of the 3 pieces as I went. Because -1/3 times 1 cubed
-1/3
minus 1/2 times 1 squared,
minus 1/2.
2 times y, or 2 times 1.
Plus 2.
Okay, now obviously it needs cleaned up, but I'll come back to that. Minus. Could you do the same thing here?
Yeah. Well,
I like to. So -2 cubed, -8 times -1/3.
-8/3.
I'm going to go positive 8/3. There's -8 times -1/3.
Oh.
Okay? -2 squared, 4 times -1/2.
-2.
minus 2. And then 2 times negative 2?
Minus 2.
Now keep in mind, I have this all in a parenthesis with a minus sign in front of it, yes. I'm just plugging values in. And from here, I don't know, you do you can clean it up a little bit. If I look at my work, I got everything with a common denominator of 6 right now. I don't know if I really needed to do that, but you could also do some cleanup as you go here, can't you? So, like for instance, negative 1/3 minus 8/3.
Negative 3.
How do I want to, okay. I'm going to, well, okay. Negative 1/3 minus 8/3 is negative 9/3, right? There's still a minus 1/2 I'm going to carry down. You guys feel like we can put all the whole numbers together? 2
Plus.
minus negative 2, so 2 plus 2 is 4, minus negative 4, plus 4 is 8. Now, Doug already said minus negative 9/3 was negative 3. I agree, I just didn't write it. Negative 3 plus 8 is 5 minus a half.
Nice.
Come on. Okay, now I really ticked it off. It won't come back. Okay, I was going to say, it's not letting me. Yeah, 4.5 is right. So 4.5 or 9/2. Okay. 9/2 is your more official calc answer.
Yeah.
Okay. You know, 4.5, and I'll say my brain says 4.5. You're never going to see a mixed number, 4.5. So 9/2 is the more official answer. Okay. Oh, you can see my graph shifted because that is not lined up now.
That looks pretty cool though. It's like,
No,
yeah,
it doesn't.
kind of like a bow and arrow.
Okay, moving on. Or if that is, if you guys are good. Okay. Find the area of the region between the graphs of f of x and g of x. F of x is which graph?
The cubed one. Yeah.
The cube one, which is
This one. Up, down.
The valley mountain.
Valley Mountain, down, up, down. Okay. G of x then is the parabola here. Okay. A asks us to find the intersection of the two curves.
Zero.
Yep.
Oh, that'd be clear.
And that one. Negative 320. And then that one up there.
Now, do we know these exactly?
We know 0, 0.
Okay. Huh?
So we can kind of see 0, 0.
Okay. I'm not going to argue 0, 0. But the other two, we don't know exactly. Okay. And it doesn't help that that vertical axis is counting by 5s, does it? Okay. Algebraically, without the calculator. In other words, without just graphing these on your calculator and finding the intersection points that way. How do you find intersection points if you don't know what they are, going back to your algebra skills?
Plug in an x value. No, I mean you can't.
Okay, so unofficially, we're pretty sure that that's 3 and negative 3. Could you plug them in, make sure they come out to the same y values? Okay. What if I don't have a graph to look at? I got to play devil's advocate here somehow.
You said equal to each other?
Okay, if we want to know where they intersect, we're going to set f of x equal to g of x. I told you, algebraically. Now, is Kylie wrong? No. Okay, it works. But that's because we have pretty good guesses of 3 and negative 3. It's the y values that are in question. Okay, so 14x plus x squared minus 2x cubed equals x squared minus 4x.
I don't even know how to do this.
Okay.
Well, I would say let's try and make the equation equal to
Zero.
0.
X squared. Subtract x squared, add 4x.
If I, negative 2x cubed, I probably should have switched this to the other side, but if I keep that on the left, if I subtract the x squared over, my x squareds cancel. If I add the 4x over, 14x and 4x is 18x. Are you with me? Now what?
Factor out a negative 2x.
GCF? Okay. Negative 2x, GCF, leaves me with
Negative 9x. And oh, negative 9. Just kidding.
I was giving you a chance to get there. If I factor out negative 2x, I have x squared minus 9. Okay. Technically, you could factor x squared minus 9 again if you want. Do you have to? No. If we set this equal to 0, what x values are we getting?
Plus minus 3 and 0.
Are you guys with them? Without me showing all the work there? Now, this verifies what we thought in terms of x values, doesn't it? Okay? And that's what I wanted you guys to see, is how do we do this when I don't have a graph to look at and give me that suggestion. Now, how do I find the y values? We're going to have to plug them in. Okay? So we know at this point, it's negative 3 something, it's 0 something, and it's 3 something. Officially, you're plugging into either F or G. And Kylie's like, this is where I wanted to go to begin with. And I know, but my question was, what if we don't know the negative 3 and 3? Okay? So, with that in mind, I personally want to plug into G, because G looks a little easier. However, if you plug into F, we should be getting the same thing, right? And if you're ever hesitant, double check yourself. Plug it into both. But let's see, negative 3 squared is 9 plus, well, minus 4 times negative 3 plus 12, 21.
Yeah.
Okay, 0. 0 squared minus 4 times 0 is indeed 0, 0 as we thought. 3. 3 squared minus 4 times 3.
9 minus 12.
9 minus 12 is negative 3. Okay, so we have 3, negative 3. We have 0, 0. And that right there was an important reason. It's actually 321, isn't it? Not 320. Okay. We are supposed to write the integrals and calculate the area. Did you notice what it says here?
Integrals.
Why does it say integrals?
Because there's 2 of them.
There's more than one area.
Yeah. You'll often see them talk about A1 and A2. Meaning we're going to find one area and the other area and have to add those together. Are you seeing that? So, like we've got A1 here, and then we've got A2 over here. And unfortunately, they're not symmetric, are they?
No.
That would be too easy. So,
And why would they?
let's start by finding A1.
The integral from negative 3 to 0.
Okay, so let's first pause. Are we good with negative 3 to 0?
Yes.
We're on the orange piece. Negative 3 to 0, because those are my x values. Because are we able to do upper minus lower?
Yes.
Are my equations in terms of x?
Yes.
Yes. Okay, so What are we doing here?
14x. Do we have to do those subtracted from each other?
Yes.
And whichever one is on the top goes first.
Whichever one's on top goes first.
So then x squared minus 4x.
G of x is on top in this case, yes? On this one, from -3 to 0, g of x is on top. So x squared minus 4x minus 14x plus x squared minus 2x cubed dx. Now, and that was doing what we decide. G of x minus f of x. Do you want to go ahead and set the other one up, or do we want to work this one out?
Work this one out and then do the
Okay. So if we're going to work this one out, I'm not going to integrate 5 terms unnecessarily when we can see it's going to come down to 2 terms. Slightly different 2 terms than earlier, though, yes? X squared minus x squared cancels. Negative 4x minus 14x.
negative 8
Negative 18x, and we're going to have a
plus.
plus 2x cubed.
Can we do that right? But just do that.
Are you saying you want to do 2x cubed and then minus 18x?
Yeah.
And again, does it matter?
Yes.
It might matter for you personally, but it does not technically matter. Okay, so this is what A1 is going to be. Let's integrate. Add 1 to the power. Divide by the new power. Evaluate from -3 to 0. Did I do that right?
Yes.
I guess you guys will yell at me if I didn't, hopefully. Okay. Now, unusual, we're plugging in 0 first, aren't we?
So 0 minus 0.
So 0 minus 0 minus, I'm going to start parentheses. Oof, -3 to the 4th.
981.
Yeah. Are you guys with them? 2 3s is 9, so 4 3s is 81. And that's going to be 81 halves. And then -3 squared is 9 times -9 plus 81?
Yeah.
Oh,
No.
No.
Minus.
yep. Minus 81. Well, eventually it'll become plus 81 here in a moment, but okay. Clean it up somehow or another, yes? So if I say -81 halves plus, if I double that to get a common denominator, 162 halves. Yeah, -81 halves plus 162 halves is 81 halves. I mean, you know, it was basically 81 minus half of 81. So, are you with me? Okay. Now I'm going to go talk A2.
0 to 3.
This time we're going 0 to 3. Then what?
14x.
14x plus x squared minus 2x cubed. And then that's minus x cubed minus 4x.
Okay, so what you should have been doing here, I didn't really talk much because I figured you guys, we talked last time, g of x was on top last time. This time, this is one of the reasons we have to do it separately, because now the cubic, now it's f of x minus g of x. Okay? We've already done this subtraction once, technically, haven't we? Because this is what we did up in part A. We're going to have
negative 2x cubed plus 18x.
dx with respect to x. You can use your integration from last time and just change your signs. So negative 1/2 x to the fourth plus 9x squared this time. This time we're plugging in 3 and then 0, which 3 to the fourth we already talked about is 81. So negative 81 halves plus 81 minus 0 minus 0. So negative 81 halves plus 81, or plus 162 halves, is 81 halves. They don't look the same, do they?
What? That's so annoying, actually.
Yeah, it's positive 81.
Okay. So over here, we found A1.
No, you don't.
Yes, I did. To be. Nope, it's not going to let me. Come on. To be 81 halves. We found A2 to be 81 halves.
Do they look like it?
What's my answer?
81 halves.
Plus
Yeah.
81 halves.
Yeah.
Which
81.
is
Okay. Okay, so yes, the point I was trying to get here is that A1 plus A2 is what you need to do to get the total area, right? So we were at 81 halves plus 81 halves, which is 81. Okay. Now, good news. Do all area problems have two pieces like this? No. Okay. And one thing I am horrible about doing, realize we are going upper to lower, yes?
Mm-hmm.
So here we are talking about vertical rectangles. Vertical rectangles because it's, going the distance between the top and the bottom. Anytime you're working with x's, they're going to be vertical rectangles. Okay. Ready for 5?
Yep.
It didn't turn back on earlier, I just realized. My computer fell asleep on me earlier. Okay. Find the area of one of the regions bounded by the sine and cosine curves. What? Well, that's part of the question. It says, so sketch note, f of x is greater than or equal to g of x. Part of it we have to decide which is f of x and which is g of x in terms of, it said find the area of one of the regions. Which region are we going to find?
I don't know, but the one starting on the bottom is f of x. Right? Yeah.
Well, isn't the
Or
region?
no, the one starting on the bottom is.
In order to define f of x and g of x, which is which, we have to pick which region we're going to talk about here.
I have a question, but I don't. Okay. So, can't we just find this one and then it'll be the same as that one?
Right.
Okay.
But then this is where, in order to talk about which is f and which is g,
Yeah.
which one are we doing?
Let's just do it first. Sine.
Okay, so
Or no.
now which region are we finding the area
Or the
between the
first
curves? So we're finding the area of this one here. Yes?
Yes.
This is why I won't respond to whether f or g is sine or cosine, because it depends on which curve we pick based on the fact that it's telling us we're using f is greater than or equal to g. So basically the curve on top is f, the curve on bottom is g. In this picture, if we're using what I have now shaded with orange, what is f?
Sine.
Now I agree. Are you guys with us?
Yes.
Sorry, I don't think you guys like the fact I wouldn't answer, but I couldn't. Because what happens if we use this one?
Cosine.
Cosine's on top if we'd use this other one. Okay, now, regardless, this guy right here is definitely sine, and this other guy is cosine.
So will they still be the same even after we, like, will both sections still be the same area?
Yeah, we only have to find one, so. Okay, so let's see. The way we're doing this is f of x, and this is g of x. Okay, B. Find the bounds, a and b, where sine x equals cosine x. In other words, we need to find this and that.
Pi over 2, or pi over 4. And what's between pi and 3 pi over 2?
So here's the deal. If you go back to the basic trig reference chart, where are sine and cosine the same? Just basic trig reference chart right there by Hannah. Sine and cosine are the same at pi over 4, yes?
Yep.
So one of these values is going to be in regards to pi over 4. And it's going to be pi over 4 comma what? No. What's the y value?
Oh,
That was very good.
Because we know the sine of pi over 4 is square root of 2 over 2. And we know the cosine of pi over 4 is square root of 2 over 2. Yes? Now, so that's this one right here. And so now we need the next pi over 4 angle. And, you know, think about it. Like this would be pi over 2. This over here would be 3 pi over 2 if we label all those pieces. This piece is quadrant 2, 5 pi over 4. Okay? Or excuse me, quadrant 3. Now, what about the y value here?
Square root of 2 over 2.
It's still square root of 2 over 2. Positive or negative?
Negative.
One reason we know it's negative is because it's below the x-axis. If you go back to all students take calculus, okay, pi over 4 is here, yes. 5 pi over 4 is here. And sine and cosine are both negative down there, aren't they?
Yeah.
Okay. Are you there? Are you with me? Okay. Let's set this up and integrate. Okay, there's my help.
Pi over 4 to 5 pi over 4.
Okay. Pi over 4 to 5 pi over 4, which we are using x's, yes?
Yes.
They have x's in them. Do we have an upper and a lower? We do. We have an upper and a lower here. So it's a vertical rectangle between them. We already talked about where it's sine x and cosine x. Okay, so pi over 4 to 5 pi over 4, then what? Sine x minus cosine x
Yes.
dx. Okay, no cleanup. We get to jump straight into integrating. Well, here's my thought. I know the integral of sine is something about cosine. I just have to personally process through, is it positive or negative? And that's hopefully where you're at, is you've got to process through, is it positive or negative? Yeah, and here's my thing. I work backwards. The derivative of cosine is negative sine, but that guy's not negative, so this one's got to be negative.
Oh.
And then this one, I carried down the minus sign. The derivative of sine is cosine, so you just carry down the minus sign. So negative cosine x minus sine x, evaluated from pi over 4 to 5 pi over 4. Okay. First of all, we're plugging in 5 pi over 4, yes? So negative cosine of 5 pi over 4 minus sine of 5 pi over 4 minus, I'm going to do parentheses for quantity, negative cosine of pi over 4 minus sine of pi over 4. I know something I would definitely do there on my own. Well, I don't know. Okay,
The cosines cancel. No, they don't.
we're not at the same angle. We can't talk about anything canceling until we have to get rid of the sines and cosines right now. So, okay, cosine of 5 pi over 4.
Square.
We already talked about this today. Cosine of 5 pi over 4,
Negative square root of 2.
negative square root. So this is going to be the negative of the negative,
Which is
So square.
so square root of 2 over 2. Minus sine of 5 pi over 4.
Square root 2.
So it's negative again, so minus a negative is going to make that plus square root of 2 over 2. Now, I don't know how you guys feel about this. You know what I kind of want to do here? It's minus, a negative, and a minus. What's this all going to become?
Positive.
Does that make it a little bit less confusing? Me personally, it does. Because now I can just say, okay, cosine of pi over 4 is,
Square root 2.
so plus square root of 2 over 2. Sine of pi over 4?
Minus.
It would be
Minus square root 2 over 2.
Everything ends up positive here.
Yeah.
What?
Because it's in the.
that's an old one.
Oh, but that's in the first.
We're in
quadrant.
first
Yeah.
quadrant here. We're not doing 5 pi over 4 anymore. We're doing pi over 4. Now, here's what my brain says. All of these are 1/2 square root of 2. What's 1/2 plus 1/2 plus 1/2 plus 1/2?
2.
2. Ah. Or 4/2. Did some of you guys do 4/2, I guess? 4/2 square root of 2, but whatever.
4 divided by
I didn't know.
I'm making you guys work your brains today, aren't I?
2. No.
I have not picked up those calculators. Hey, if we make it to example 7, we get to pick up a calculator. Okay. Yeah, 6 is long, but I think we can do it. Okay. The graph of the function g consists of a quarter circle and 3 line segments shown at right. Let f be the function defined by the integral from -1 to x g of t dt. Okay. And then we have an a, b, c, d. Yes? Okay. Let's see. So first of all, okay, and that's why I had to go back and figure out, what is this graph of?
G.
This is g, yes? This is g of x. So just realize that. So this is what's being integrated, right? Okay. Now, they want us to find, to start off with, A, they want us to find f of -5. Well, how am I going to find f of -5? F of -5 is the integral from -1 to -5 g of t dt.
But then don't you have to put it?
Okay, so good. What Sophie brought up earlier. Okay, our brains are on it. We can't do -1, -5. We can't have the bigger bounds on bottom, so this is now going to become the negative of the integral of -5 to -1 of g of t dt. Okay. Now what? By the way, guys, FYI, mine's not going to end up fitting right. I have like 4 different sections here because we have 4 parts to do. Okay, so I'm warning you now. You guys should be okay. I'm not going to be, but. Okay, how do we do this area? Or excuse me, how do we do this integral? I gave myself away. Do we have a g to integrate? No.
So we just
But we have a g,
prime.
we have a graph.
We got
What's integral mean?
areas, triangles.
Area under the curve from -5 to -1. Okay. So I know there's a negative out front. I got that far. What's the first piece you see?
1/4.
Negative.
Okay.
I see that -3, -2, and -2, -1 are symmetrical. So
Hold on. I'm going left to right. What's the first one?
No,
Over 4. No, 4 pi.
How do we do the first one?
It's pi r squared.
Area of a circle is pi r squared. This is a quarter circle, so we're going to do 1/4. Are we there? Which I think a lot of you were there. I think a lot of you were ahead of me, to be honest.
Oh, and the radius is 2, so it's just pi.
Radius is 2. So you're going to be doing 1/4 pi times 2 squared,
Pi.
which is going to be pi.
W, Natalie. High five.
Okay.
Got that one.
Now, what about from -3 to -2?
It's the same as -2 to
Okay, and what's good to know there?
-1.
They cancel.
Okay. Are they going to cancel?
Yes.
Now, while we're here, in case it comes up later, what are each of those areas? I'm trying to remember if we have to use it later or not.
1.
1/2 base times height, right?
1 and -1.
And so base of 1, height of 2, 1/2 times 1 times 2 is 1. This one is also 1, but it's below the x-axis, so it is a -1. Okay, so this is, I'm going to write it as the negative of pi plus 1 minus 1, just because I can. But it is coming up to be
-5.
-pi. Okay, are you guys with me on A?
Yeah.
Let's talk B. Find all the values of x on the open interval, -5 to 4, where f of x is decreasing. Justify your answer.
Where do you have B on your paper?
I personally have it over here. I'm not sure it's really going to work. I have A, B, C, D on mine, but in all honesty, it might be better for me to switch those, but it is what it is. Mine's not going to fit. Okay. Values of x, -5 to 4, where f is decreasing.
-2 to -1. Right?
Yeah.
Because it's whenever the signs are the same.
No. It's whenever the signs are opposite. We're gonna have to find the area of the other two.
-3 to -1.
Well, it's not.
For decreasing, it's when that signs are opposite.
We're being asked about f.
I don't know if we're doing G.
Oh.
We need to be doing that.
Oh, sorry, we're doing that.
What is f? F is just defined to be the integral of g.
So that's the derivative of f.
Yeah.
So -2 to negative. No, it's -2 to 1.
Yeah.
Yeah.
Yeah, because it's below the x-axis.
Okay. So here's the deal. We're being asked to find f. What we know is that if you take the derivative here of f, the derivative of f is g. What is this graph? This graph is g. So we want to know where is g negative then. And we start talking about where is g negative, that is on the -2 to 1. So I have mine written as f prime of x is less than 0 on -2 less than x less than 1. So f of x is decreasing on -2 less than x, less than 1. So yeah, all that to say, -2 to 1. Okay, see when you're ready.
You're so I'm laughing.
Write an equation.
Write an equation for the line tangent to the graph of f at x equals -1.
Life is it.
No. Now, we're writing an equation for the line tangent to the graph of f. So, let's first of all talk.
That's a min.
Okay. Well, in order to write an equation of a line, you need a point and a slope. Yes?
Yes.
So, let's talk slope first. If we want the slope, we need to know f prime of -1. Yes? Well, what do we know? F prime of -1 really means we're finding, what does f prime of x equal? G of x. So that really means we need to know g of -1. What is g of -1? G of -1 is equal to -2. So what is this -2 I just found? This is my slope. Now, we also need a point. So f prime of -1 gave me the slope. F of -1 is going to give me a point. How do we find f of 1? F of -1, go to your integral. So it's going to be the integral from -1 to -1 g of t dt. What is an integral when the bounds are the same? 0. Because if your bounds are the same, there's no area between them, right? So thus, 0. So what is my point then? -1, 0 is my point. I'm running out of room, but you can write the equation of a line, yes? I tend to start off point slope. Some calc teachers do variations of that, but y minus 0 equals -2, x minus -1. So, which I just left mine actually as -2 times x plus 1. What did you say for your answer, Doug?
-2x.
Okay, that would be equivalent. Okay. And D. Oof. Good point if we can get to 7, it's quick. Okay. D. Find the minimum value of f on the interval -5 to 4. Justify your answer.
It's either -2 or 1. Because those are right. That's right, right?
-1.
It'd be 1 because it's going from decreasing to increasing. The other one's going from increasing.
Oh, yeah, okay.
Oh, you have to include it twice.
Oh my gosh.
Okay.
Where
So we have to do the
crosses
campus
the
test.
x-axis.
Okay, we are talking f of x. Now, it is on a closed interval. So we do have to consider endpoints. So -5 and 4. Then, at first it was mentioned 2 critical points, yes? And critical points are when the derivative equals 0, right? Well, f prime, the derivative, is the same as g. When does g equal 0? -2 and 1. I'm going through the reasoning. Bear with me. Don't crucify me for putting that extra number there for a moment. Now, we are looking for a what? Minimum. Some of you already ruled one of those out, and I totally agree. Okay, a minimum, well, this one goes from positive to negative. So it's going to go from increasing to decreasing. So guess what? Wait a minute. Oh, and that's -2, isn't it? Huh. So could that one work? No. You don't even have to consider that one, do you? It cannot be a minimum. Could -1 be a minimum? Or +1?
Yes. Yes.
Yes, because it's going from decreasing to increasing. Okay. You need to find these values. Okay. It's F. So F means we're plugging in here, yes? Now, have we done any of these? We have. So this first one, -5, is going to be, have we done F of -5? F of -5 is -pi. Steal your own answer. Have we done F of 1? We have not. So F of 1, we need to know this piece right here.
It's pi plus
Let's see, 1/2 times 2 times 2.
2.
So 2 times 2 is 4. This is going to be a -2 here, yes?
Pi minus 2.
So from, oh wait, what are we doing? If it's F of 1,
It's only -1 to 1.
yeah, are you guys catching me?
So then it's -2.
F of 1 is going to be -1 to 1. So what's -1 to 1? -2. F of 4 is going to be the integral from -1 to 4. Well, what's the other piece? I need a triangle that is 1/2 times 3 times 1. So half of 3 is 1.5. And if we're going from -1 to 4, -2 plus 1/2, or plus 1.5, -0.5. Okay, where's our minimum?
-5.
Okay. Now, -5 would get you wrong. Find the minimum value. Well, I guess I asked where is the minimum, didn't I?
Yeah.
You answered me right, but what do we answer the question?
-5.
-5. Okay. So I have written in mine a big explanation. Minimums occur at endpoints. Changes from day, yeah. So minimum of -pi occurs at x equals -5. There's a lot more stuff we could write, but we're out of time. So if you glance at 7 real quick, the density of cars on 10 miles of the highway approaching Disney World is approximately, and they give you this formula, right? Where x is the distance in miles from the Magic Kingdom entrance. Find the total number of cars on this 10-mile stretch. How are you going to find that accumulated amount of cars?
0 to 10, and then plug that in.
You're going to do the integral from 0 to 10 of f of x dx. And that's going to be done on the calculator, right? Okay. I will have to check and see if I have answer keys posted or not. Okay, see what you guys can do with that stuff.